The monarch butterfly enters the world not as a symbol, not as a myth, but as a biological experiment refined through millions of years of evolution. Long before humans named it, studied it, or printed it on posters, the monarch was already perfecting a survival strategy that defies scale. It is an insect that weighs less than a paperclip yet moves across a continent with purpose, precision, and timing that rivals the migrations of birds and mammals many times its size. Its evolutionary lineage traces back to a time when flowering plants reshaped the planet's ecosystems. As angiosperms spread, insects diversified alongside them, forming intimate relationships that would define both survival and extinction. The monarch butterfly emerged within this dynamic biological arms race, specializing not in speed or aggression, but in chemistry, memory, and endurance. Its ancestors that failed to adapt vanished quietly. The ones that learned to feed, to travel, and to avoid predation through deception became what we now recognize as the monarch. Physically, the monarch butterfly is instantly recognizable. Its wings are painted in a pattern so bold that it almost seems reckless, bright orange fields framed by thick black veins and bordered with white spots. In nature, brightness often signals danger, and in this case, the signal is honest. Monarchs are toxic to many predators, a trait acquired during their larval stage when caterpillars feed exclusively on milkweed plants. These plants contain cardiac glycosides, chemicals that disrupt heart function. Rather than avoiding them, monarch caterpillars absorb and store these toxins, carrying them into adulthood as a built-in chemical defense. This toxicity reshapes the monarch's entire relationship with the world. Birds that attempt to eat one often vomit violently and remember the experience. That memory spreads across predator populations, granting monarchs a rare privilege in the insect world: visibility without vulnerability. Their colors are not camouflage, they are a warning label written in wing beats. The body of the monarch is engineered for endurance. Long, narrow wings reduce energy expenditure during flight. The thorax houses powerful flight muscles capable of sustained motion over hours. Unlike most butterflies, monarchs are not limited to short, erratic movements between flowers. They are capable of directional flight, adjusting altitude and orientation using sunlight, magnetic cues, and internal circadian clocks encoded deep within the nervous system. Even their fragility is deceptive. A monarch's wings may tear, fade, or fray, yet the insect continues flying, feeding, and migrating long after another species might collapse. Each scar becomes a record of distance traveled, storms endured, and predators escaped. No two migrating monarchs look identical by the end of the journey. Each body becomes a living map of survival. What makes the monarch butterfly truly exceptional, however, is not its appearance or toxicity alone, but the way its life unfolds across time. Monarchs do not complete their famous migration in a single lifetime. Instead, the journey is divided across generations, with each butterfly inheriting a destination it has never seen. Memory, in this case, is not individual but biological. Direction is not learned but encoded. This is where the monarch stops being just an insect and becomes a phenomenon. To understand the monarch butterfly in motion is to observe a creature governed not by instinct alone, but by rhythm. Its daily life unfolds according to patterns shaped by temperature, light, wind, and availability of food. Unlike insects that exist in frantic bursts of activity, monarchs move with restraint. Energy is conserved, decisions are delayed, and actions are measured. Every wing beat has a cost, and the monarch behaves as if it knows this. The day begins with warmth. Monarch butterflies are ectothermic, meaning their body temperature depends on the environment. In the cool hours of morning, they perch quietly, wings spread wide to absorb sunlight. This posture is not passive, it is calibration. Only when their muscles reach a precise thermal threshold can flight begin. Too cold, and the wings fail. Too hot, and dehydration threatens. Timing is everything. Once airborne, monarchs adopt a style of flight that is surprisingly efficient. They glide when possible, riding thermal currents and wind drafts rather than fighting them. During migration, this behavior becomes critical. Monarchs do not fly continuously. They move in pulses, resting frequently, feeding whenever nectar is available, and adjusting course subtly rather than dramatically. This slow, deliberate movement allows them to travel vast distances without exhausting their limited energy reserves. Their feeding behavior reflects this same efficiency. Adult monarch butterflies feed exclusively on nectar, drawing sugars from flowers using a long, coiled proboscis. Unlike larvae, adults are no longer toxic by ingestion alone, they rely on stored chemicals from the caterpillar stage. Nectar provides fuel, not defense. Monarchs show preference for certain flowering plants, particularly those that bloom during migration periods, creating invisible highways of sustenance across landscapes. Habitat, for the monarch, is not a single place but a sequence of environments stitched together by seasons. During breeding months, monarchs inhabit open fields, meadows, grasslands, roadsides, and agricultural edges, anywhere milkweed grows. Milkweed is not optional. It is the sole plant on which monarchs lay eggs and the only food monarch caterpillars can eat. Without milkweed, the monarch life cycle collapses entirely. As seasons shift, so does the monarch's definition of home. In late summer and early autumn, a specific generation of monarchs emerges with a radically different purpose. These butterflies do not reproduce immediately. Instead, their bodies enter a state known as reproductive diapause. Energy that would normally go into mating and egg production is redirected towards survival and flight. This generation is built to migrate. Their behavior changes noticeably. They become less territorial, more tolerant of proximity to other monarchs. Large groups gather in roosting clusters, clinging to trees overnight to conserve heat and reduce predation. At dawn, they lift off together, forming loose aerial streams that drift southward, guided by environmental cues that science is still unraveling. Daily life during migration is austere. Feeding opportunities are taken quickly and without ceremony. Resting sites are chosen for shelter rather than abundance. Monarchs avoid unnecessary risks, steering clear of heavy rain, strong winds, and extreme temperatures whenever possible. When conditions turn hostile, they wait. Patience is not a luxury, it is survival. Outside migration, monarch behavior becomes more localized and intimate. Males patrol territories near milkweed patches, searching for females. Courtship is brief but precise, involving aerial pursuit and pheromone signaling. Once mating occurs, females embark on a solitary mission, to lay eggs one by one, each placed carefully on the underside of a milkweed leaf. There is no parental care beyond placement. The choice of leaf is the final gift. The egg stage lasts only a few days. From there, the caterpillar emerges into a world defined entirely by consumption. Monarch larvae eat relentlessly, shedding their skin multiple times as they grow. This phase is dangerous but essential. Every bite of milkweed strengthens the chemical defense while building the mass needed for metamorphosis. Behavior here is simple but relentless: eat, grow, survive. Even at this stage, monarchs exhibit subtle behavioral adaptations. Caterpillars feed in patterns that minimize exposure to predators. The distinctive black, white, and yellow stripes signal toxicity early, discouraging attacks before they happen. When threatened, they may thrash or drop from leaves on silk threads, escaping danger without expending unnecessary energy. Throughout all stages of life, the monarch butterfly exists in a constant negotiation with its environment. It does not dominate its habitat, it listens to it. Wind direction, daylight length, plant chemistry, and temperature shifts all influence behavior in real time. The monarch is not reactive in a chaotic sense. It is responsive, adaptive, and restrained. This balance between fragility and discipline is what allows the monarch to persist in environments that change faster than most insects can tolerate. It is not the strongest flyer, the fastest reproducer, or the most aggressive survivor. But it may be one of the most precise. The migration of the monarch butterfly is not a journey in the traditional sense. It is not a single voyage with a beginning and an end understood by those who travel it. Instead, it is a biological relay race carried across time, space, and generations. No individual monarch completes the entire cycle, yet the species moves as if it remembers. Each autumn, as daylight shortens and temperatures dip, a signal ripples through monarch populations across North America. Butterflies that have never migrated before suddenly change. Their bodies develop thicker wings, increased fat reserves, and altered hormone levels. Reproduction pauses. Longevity increases dramatically. A monarch that might live a few weeks in summer now survives for up to 8 months. This is the migratory generation. They begin moving south. From Canada and the northern United States, monarchs funnel towards central migratory corridors. Some travel along the Atlantic coast, others through the Central Plains, and many converge toward Texas before crossing into Mexico. The distances are staggering, thousands of kilometers, covered not in straight lines but in gentle arcs shaped by wind, weather, and terrain. How monarchs navigate remains one of the most studied and debated questions in insect biology. They do not follow landmarks in the way birds do. They do not learn routes from elders. Instead, monarchs rely on a combination of internal and external guidance systems. A sun compass allows them to maintain a consistent heading relative to the sun's position. This compass is linked to an internal circadian clock, compensating for the sun's movement across the sky throughout the day. When clouds obscure the sun, monarchs do not panic. Research suggests they can sense Earth's magnetic field, using it as a backup navigation system. This ability, rare and poorly understood, allows them to maintain direction even under overcast skies. Navigation, for the monarch, is redundant by design. Failure is not an option. Migration is not constant flight. Monarchs travel by day and rest by night, clustering in trees to conserve warmth. These roosts can contain thousands of individuals, transforming entire branches into living tapestries of orange and black. At dawn, they warm their wings together, then lift off in waves, continuing the journey. The final destination is astonishingly specific. Monarchs from across an entire continent converge on a small region of high-altitude forests in central Mexico. Here, OML fir trees provide the precise microclimate needed for winter survival, cool enough to slow metabolism, warm enough to prevent freezing, and humid enough to prevent dehydration. None of the butterflies arriving have ever been there before. They remain through the winter in a state of suspended animation. Movement is minimal, feeding is rare, energy is rationed carefully. Storms, however, can be catastrophic. Heavy rain followed by freezing temperatures can kill millions in a single night. Even here, at the journey's end, survival is fragile. As winter loosens its grip, something shifts again. Hormones change. Reproductive systems reactivate. The monarchs leave the forests and begin moving north, laying eggs along the way. These offspring will continue the return journey, passing the migration baton to the next generation, and then the next, until the cycle completes. This multi-generational migration is unparalleled among insects. It requires precision not just from individuals, but from ecosystems across thousands of kilometers. Milkweed availability, flowering plant timing, weather stability, and intact habitats must all align. When even one link weakens, the entire chain trembles. Survival during migration depends on constant compromise. Monarchs must avoid predators without hiding, conserve energy without stopping, and adapt to weather patterns that shift unpredictably. Wind can carry them hundreds of kilometers off course. Heat can desiccate them, cold can immobilize them. Human-made obstacles, roads, cities, pesticides, add new hazards evolution never prepared them for. And yet, monarchs persist. What makes this persistence extraordinary is not resilience alone, but accuracy. Year after year, generation after generation, monarchs arrive within kilometers of the same overwintering sites. They do not overshoot. They do not scatter randomly. They arrive as if guided by a memory written into their cells. This journey is not an accident of behavior. It is a structure encoded by natural selection, refined by failure, and maintained only through success. Monarchs that wandered too far, left too early, or failed to synchronize vanished. The survivors became the standard. In this way, migration is not something monarchs do. It is something they are. The monarch butterfly does not exist in isolation. It is woven into ecosystems as both participant and signal, influencing and reflecting the health of the environments it passes through. Wherever monarchs travel, they interact with plants, predators, parasites, and climate systems in ways that ripple outward. Their presence is subtle, but their absence is loud. As pollinators, monarch butterflies contribute quietly but consistently. While they are not as efficient as bees in terms of pollen transfer, their long-distance movement allows them to connect plant populations separated by great distances. Each feeding stop becomes a point of genetic exchange for flowering plants, especially late-blooming species that rely on migrating insects for reproduction. In this way, monarchs act as biological messengers, carrying pollen across regions that might otherwise remain isolated. Beyond pollination, monarchs play a critical role as prey, paradoxical as that may seem for a toxic insect. While many predators avoid them, some have adapted. Certain birds, insects, and parasites tolerate or circumvent monarch toxins, incorporating them into the food web. Monarch caterpillars and adults also host a range of parasites, making them indicators of disease dynamics within insect populations. Their health reflects the balance, or imbalance, of the systems they inhabit. Because of this sensitivity, monarch butterflies are considered a bioindicator species. Changes in monarch population size, migration timing, or survival rates often signal deeper environmental disruptions. When monarch numbers fall, it is rarely due to a single cause. It is the cumulative result of habitat loss, chemical exposure, climate instability, and ecological fragmentation. In recent decades, these pressures have intensified. Milkweed, the foundation of the monarch life cycle, has declined sharply across much of North America. Agricultural expansion, urban development, and roadside maintenance have eliminated vast stretches of milkweed habitat. Modern farming practices, particularly the widespread use of herbicide-resistant crops, have further accelerated this loss. Fields that once supported monarch breeding have become biological deserts. Climate change adds another layer of uncertainty. Monarch migration depends on precise seasonal cues, temperature, daylight length, flowering schedules. As climates warm unevenly, these cues fall out of sync. Monarchs may arrive too early, before nectar plants bloom. Caterpillars may hatch when milkweed is scarce or stressed. Extreme weather events, including droughts, heatwaves, and unseasonal freezes, disrupt migration corridors and overwintering sites. The overwintering forests themselves face existential threats. Logging, illegal land use, and climate-driven forest degradation reduce the quality and extent of the habitats monarchs depend on for winter survival. A single severe storm in these regions can wipe out a significant portion of the global monarch population in days. Human infrastructure further complicates survival. Roads fragment habitats. Artificial lighting disorients migrating butterflies. Vehicle collisions kill countless individuals, especially during peak migration periods. Pesticides, even those not intended for insects, contaminate nectar sources and weaken immune systems, leaving monarchs more vulnerable to disease and predation. Yet despite these pressures, the monarch butterfly has not disappeared. Conservation efforts, though uneven, have demonstrated that recovery is possible. Milkweed restoration projects, pollinator-friendly gardening, changes in roadside management, and protected overwintering reserves have all shown measurable benefits. Monarchs respond quickly when conditions improve. Their reproductive rate allows populations to rebound, provided the ecological scaffolding remains intact. What makes monarch conservation uniquely compelling is its accessibility. Unlike many endangered species, monarchs do not require remote wilderness to survive. They can breed in suburban gardens, along highways, in city parks, and on small patches of land. This proximity transforms conservation from an abstract concept into a personal choice. Every milkweed plant matters. Every pesticide avoided matters. Every corridor preserved matters. The future of the monarch butterfly is not yet written. It balances between persistence and collapse, shaped by decisions made far beyond the insect itself. Monarchs have survived ice ages, continental shifts, and millennia of natural change. What they now face is something evolution did not prepare them for: rapid, human-driven transformation. Still, the monarch continues to fly. Each autumn, when orange wings appear against fading summer skies, the migration begins again. Not because the world is safe, not because success is guaranteed, but because the species remembers what it has always done. Movement, in this case, is faith encoded in biology. The monarch butterfly does not conquer its continent through strength or numbers. It does so through continuity, through patience, through an unbroken chain of lives, each carrying a fragment of a journey larger than itself. And as long as even a few of those wings remain in the air, the story continues.